Congruence and Transformations, Lesson 7.1. The standards are 8G1, 8G1A, 8G1B, and 8G2. The objective is to use a series of transformations to create congruent figures. The essential question is, how can you determine congruence and similarity? Shapes are congruent if you can translate, rotate, or reflect them. If that's the only thing that happens to them, then they are congruent. Now remember, congruent shapes mean same shape, same size. Example number 1. Determine if the figure is congruent by using transformation. Explain your reasoning. So I can either translate it, rotate it, or reflect it. So let's try to translate it. So I'm going to slide it down. Okay, that's not going to work. So let's see if I can rotate the figure. Okay, that's not going to work either. So let's try to reflect it. So I'm going to reflect it down and then slide it. Okay, it looks like that works. So that means that A is congruent to B. So they are congruent because A can be reflected to make B. Example number 2. Determine if the figure is congruent by using transformation. Explain your reasoning. So first we're going to try to translate it, then rotate it, and then reflect it. So if I were to translate it, that's not going to work. So let me try to rotate it. Okay, rotating does not seem to work either. So let me try to reflect it and see if that will work. Okay, so reflecting it does not work either. Okay, the reason why none of these options work is because these shapes are not congruent. Example number 3. What transformations could be used if the letter W is the preimage and the letter M is the image in the logo shown? Are the two figures congruent? Explain. So I noticed that if I were to translate my preimage to my image, that would not work. So what I'm going to try to do is reflect it. So if I take my preimage and reflect it, that would work. So now I'm going to try to rotate my image to form my preimage. So I'm going to rotate 180 degrees clockwise. Now remember, clockwise means to the right, and 180 degrees means 2 turns. So let's try it. So this is turn 1, this is turn 2. And it does work. So that means that W is congruent to M. So the W can either be reflected up or rotated 180 degrees clockwise. Example number 4. A transformation is applied to triangle MAC to form another triangle not shown. Then a transformation is applied to that triangle to create the final one, triangle Von. Describe the set of transformations. So the first thing I'm going to try is to rotate my preimage 180 degrees clockwise. Now remember, 180 degrees means 2 turns, and clockwise is the same direction as a clock, so we're going to be moving towards the right. So let's try it and see if it works. So this would be my first turn, and this is my second turn. Now let's see if that worked. Okay, we're not quite on top of the image. It looks like I might have to translate it up 2 units. So let's try it. 1, 2. Now we are right on top of the image. So that would be my first way. So the first way would be to rotate Mac 180 degrees clockwise. Then translate up 2 units. So now I'm going to show you another way to get the same answer. So I'm going to start with my pre-image, and I'm going to reflect it over the x-axis. So I'm going to flip it up. Now I'm going to reflect it over the y-axis. So I'm going to flip it to the right. So let's see if we're on top of our image now. No, but we're pretty close. It looks like I just need to translate it up 2 units. So here's 1 and 2. Now we're right on top of our image. So that would be the second way. So the second way would be to reflect Mac over the x-axis. Then reflect over the y-axis. Last, I'm going to translate up 2 units. And those are the 2 different ways on getting the same answer.